Okay, so we talked a little bit about iterables, things that we can iterate over them. Let's see one example of how we can make some transformation on such iterables. And let's pick one of them, a simple one, a list. So we have a list of numbers and we would like to do some transformation on these numbers. Now this transformation can be a complex one that deserves a whole function to write, but I didn't want to go have some complex thing here. So the only thing I did here is I called I just duplicated the number, doubled the number, so multiplied this by 2, but I also wrapped it in a function to imitate the same idea that this is something more complex and it needs a function separately. So what you probably would do in this case is that you create a list, which is, let's say in this case, double numbers, an empty list, and then we iterate over each element of the original list and call the transformation function. And the result, we append the result to these double numbers. So that's one way to do it, of course. There are many other ways, and that's what we're going to see. And what are the advantages of these other ways? So this is one of the ways, and then we can print out these double numbers list, and then we get the numbers as doubles. Of course, the same thing would be, we could do a similar transformation using anything that's iterable. So we can iterate over on everything, call some function on the individual elements, and then append them to a new list. So that's one way. But there is another way which is way better. It's calling using the map function. So what does the map function do? The map function gets two parameters basically. The first one is the transformation. So it's a function that will transformate the values, and the second one is some iterable. In our case, so just going back to the same example, we have the list of numbers here, and then we call the map function. So but please note, we are calling the map function, and here we're calling the print function. In both cases, we have parentheses immediately after the name of the function. In this case, the double function, we don't call the double function. We pass it as a parameter to the map function. So it's just a parameter, it's not executing at this point. And then we get back something that we call the double numbers. If we print out the double numbers as we did earlier, what we get back is this output, map object, and some address, hexadecimal number. We don't get back the actual list of numbers. What we can do is we can iterate over the numbers, iterate over the double numbers list, and get those values that we're expecting. So far is good. So it's quite similar, the result that we get, but it's not exactly. It's just we get back something, an iterable, a map object, that we can iterate over to get the values. Now we can also actually call the list function on the result of this map. So we could call the map and on that immediately call list, and in that case we would get back the double numbers. We would get back the actual list. And so in this case I just printed out the double numbers. You can also iterate over them and so on. So in this case you don't need to iterate over if you don't want to, if you just want to print them out. So why would the first one be even interesting? What values do we get from the fact that map doesn't return the list already, but it just returns an iterable, a map object? The two main advantages. One of them is the size of it. So what map returns, in this case I'm showing it, what we return map is in the double iterable, and the other one when we call the map and the list on it, and this is the double numbers. So remember, double iterables is just the map object, and double numbers is already the list. If we take the size of them, then you can see that the numbers, so the list, already takes 112 bytes, and the iterable is only 48. And the iterable won't change even if this list is growing. So even if the list has 1,000 elements or 1,000,000 elements, the iterable doesn't change. It's going to stay the same. The double numbers will grow according to the size of the list. Okay. So one of the reasons to use map instead of also already converting it. So instead of also converting it to a list, is that you save a lot of space because you don't need the space for the next one. The other one is speed, actually. So let's see what happens when you call the map function. So now, in order to show this, I added a print function into this double function. So we'll see when is this double called, and you'll see that when we call the map function, the double function is not actually called immediately, only when we start iterate over the values. So we are delaying the call of this map function, and if this is a complex operation, then it means that we are not doing all the computation up front, but only when we actually need that. Okay, so let's see the output of this. The first thing is printing out, the first thing that we'll see is the result of printing out the double numbers, which is just the iterator and the map object. And then when we start the iteration, then we'll see that first it calls the double, it prints out double something, so it calls the double function, and then prints out the result because of this print function. So you can see that that if you didn't iterate over these numbers, then we wouldn't actually execute any of the functions. And why is this interesting? So let me show you an even better example for this. Let's see, we have a longer list, okay, and what we are looking for is that we have this iteration on the case in this converted numbers, in this case double numbers. Again, you should imagine something more complex, and then we are looking for some value here. Let's say we are looking for the first number that is greater than 42. Okay, we don't know upfront, of course. Yeah, it's double number, so you would probably be able to do that in a different way. But you're looking for something, and you would like to stop at that point. You don't want to go over the iterations again. Now, in this case, what you will see is that this will start iterating. We'll do the first, the second, the third, and then when it reaches the 23, that actually when it stops. So instead of calculating the double value of all of the original numbers, it stops it only calculates the first few ones up to the point where we actually stop the iteration, because at that point we stop the iteration, we don't need the data anymore. If we were converted the whole thing using the list, or if map was returning a list, as it was, I think, in Python 2, then you would do all this calculation up front, and you would basically waste a lot of CPU power, even if you don't need it. And then we can also see the size. Of course, it's even more clearer than the size of the numbers of the list is much bigger. In this case, I showed the original list, and then the the map iterator. Okay, and the last thing that I would like to show is that in the simple case, when the conversion is rather simple, so for example in this double case, we don't really need the separate double function. We could use a lambda function instead. So in this example, what we see is we are also using the list here just because I wanted to show the results quickly here. But instead of having a separate double function, instead of that we have a lambda function here that gets a single parameter and then returns the double, multiplies that value by 2, and that's what it returns. And in the next video we're going to talk about lambda. What is lambda and how else can you use it?